Hello and welcome to the fifth video in this series. In this video we'll be taking a look at the freeze node. So we currently got up to this point here, and the next one in the list is this, so I've just pulled this directly into the Xpresso window. And also in the scene you can see I've pulled in two different cubes, coloured the cubes just so we can differentiate between both of them. One of the cubes will be moving up and down in the Y position, and that's driven by a vibrate tag. It's just moving up and down in Y, and what we want to do is create a switch that we can switch on and off, and we can drive another object based on that checkbox being switched on and off. And we also want to kind of keep, rather than when the switch switches off it defaults back to a particular position, we want it to save or remember where its previous position was when it was switched off. So I'll just hit play on this, you'll see kind of what's going on here. So you can see this box on the right, so this box is being driven by this box here. It's been driven on the Y value. So what I can do here is we can just keep hitting play. If I hit the freeze node and hit the switch, you can see it loses the connection. So what it's doing at that point is, if you can see the live update through Xpresso. So if you're not 100% sure what's going on, especially through animation, pull out a result node. And also if you go to calculate, just make sure animation refresh is on, and then it'll update in real time. You can see what's going on here. So if we check this box, you can see it's still outputting a value of -41, but it's a constant value. It's no longer being affected by the box on this side. So what this node does is it's quite simple. All it does is it allows a value to be fed all the way through, so it's fed into the value position and then outputted into another port. And what happens if the switch is activated, receives like a value of 1 or a true value, it obviously flows through. If it's false, then it's switched off, and it will just keep a constant value flowing into this port here. And then again, when it's switched back on, it will allow that updated values to kind of be fed back through again. So it's quite basic. There's not really that much to it really, and I think that pretty much sums that up. Don't think there's anything else. What else we've got? Switch value. Yeah. So you could create your own user data switch here, and have your own custom switch being fed in. You could feed this statement and drive it off of a condition. And there's no other outputs. So yeah, that's pretty much what that does. So we'll now just move over to Python and recreate the same setup. So I'll just delete that tag just to make sure it's not affecting anything in the scene. We'll go into Python. We'll just delete these. And what I've done, I've already kind of created some user data, because what we want to do is we need data to be taken from this object, and we need it to be placed into this object. So we need these link slots here, and those can be set up like we've done before with going to user data, manage user data, and we just created two links, an additional Boolean switch, and that'll act as our on-off switch. So first thing, we just need to declare a couple of variables here. So the first one, we'll keep it the same as the user data, just so it's simple. I'll just call this driver. So driver equals op for operation, and then we'll just pull this onto here and just do the same thing. So driven equals op, drag this one on, and now we've placed both of these. So all this code is doing is just pulling this into this variable, and this into this variable. So have them, we'll just leave a bit of space just to keep things a bit clearer. Yeah, so the next thing we want to do, we want to take the Y positional data from this red box. So this is the driver. So now we've declared the variable, we can type in, we'll just put print to start with, just so we can print the value. And that'll be driver dot get mg dot off. So we're getting the offset, which is the positional data. We only need the Y value, so we'll put 1 in this. And after we execute, we'll just bring up the console, pop it to the side there, clear it, execute. You can see we've got 37.994. And both these values should then match. So if we hit this, you can see we've got this value matching this value, and that's exactly what we want. So we know this is working, and we know it's extracting the correct data that we need. Okay, so we've got that in place, and now what we need to do, we need to create another variable actually for the switch, and that's switch here. So let's just call this switch equals op. Pull that in. Okay, so we need to put in a condition here, and that condition needs to be something like if, say, switch is not equals to true, then we need to do something. So then we need to take that data that's being read out and read that directly into the other cube. So we need to make this cube, so we've got that which is driven. So driven, and then we'll just pull in the value. So we want to drive the Y value, and then what we want to do here is make it equal to the driver dot get mg open close brackets dot offset, and then we want 1 for the Y value. So got that. Let's execute that. No errors. We'll just hit play. Okay, so you can see it's moving with it up and down. The slight delay is probably like a priority issue, and we'll take a look at that in a second. But hopefully now, if I just check the box, yeah, you can see it's kind of leaving it at that default position wherever it left off. So as soon as we check this again, it should jump back to the same position as the red box. Yeah, that's exactly what we want. Just click on the tag, go to basic, and let's just change this from expression to generators. Okay, so you can see what it's doing now is it's running the priority of the generator, which is this, and the Python tag in a slightly different order, just so we don't get any lag. And just make sure that it's still working. Let's go back to user data, hit play, hit switch. Yeah, and there's less of a lag going on there. So that's pretty much done everything we need. So just quickly summarise what we've done here. We've pulled in 3 different user data types. So we had user data for the driver, the driven slot, and the switch, which is obviously the checkbox. And then what we've done is we've created this condition So what we're saying is if the box is not equal to true, so if it's false, so if it's untracked, we want to take the y value, so from driven, so which is the green box. Let's just move this down so we can see. So we want to take make the y value of the green box equal to the y value of the red box here. So we're pulling out the y value and we're making it equal to the driver. We're getting the matrix, we're then getting the offset, and then we're getting the y value. So that's being set if that condition. So if the box is checked, it's doing this on every frame. So I hope you found this useful. Thanks for watching the video. If you have found it useful, please like the video, and I'll catch you on the next one.